In early 2026, the GPT-5.6 family began rapidly overtaking nearly every public performance benchmark in the AI industry. On the Public Coding Agent Index, GPT-5.6 Sol hits a record high score of 80 points. But on Toloka AI's private panel of 711 enterprise tasks, the results invert. GPT-5.6 trails GPT-5.5, with success rates dropping by up to 8.7 points. These private tasks require more than just writing code. They demand precise database mutations, accurate ticket routing, and absolute verification of the final system state. Paradoxically, the model is actually better at following technical rules. It achieves a higher rate of correct tool schema adherence than the generations that came before it. Public agentic benchmarks measure raw reasoning capability, but they can mask significant operational flaws in terminal state control. In a deterministic enterprise workflow, every API call has a permanent consequence. You are modifying live payroll records, updating inventory counts, or customer databases. In these environments, GPT-5.6 performs the initial steps correctly. It retrieves the necessary policy and formulates the right context to solve the user's request. The breakdown occurs after the intelligent reasoning is finished. The model completes the planning, but fails during the final execution loop. GPT-5.6 did not lose its intelligence. It lost the ability to control how that intelligence is converted into a terminal state mutation. This suggests that smarter reasoning models can actually become less reliable when placed inside fixed, deterministic agentic loops. To understand why a more capable model would fail a routine task, we have to look at the Toloka event ledger, which tracks every trajectory the model took. Aggregate tool errors fell by 11.7 points because GPT-5.6 was better at following tool schemas in environments like airline booking. However, repetition increased. Exact duplicate API calls increased by 8.5 points. We also see an increase in write reversals. This behavior rose by 3.8 points. This pattern is called surplus action. The model finds the correct solution and then continues to act unnecessarily. GPT 5.6 actually checks the target state more frequently than its predecessors. It reads the record, confirms the job is done, and ignores that verification to write to the database again. Better tool adherence gives the model more successful ways to touch the system, which it then uses to execute destructive surplus actions. We can see this mechanical failure clearly in an audited enterprise scenario, a travel cancellation that includes a non-refundable $35 fee. The baseline GPT 5.5 computes a $662 refund, executes it, and stops. GPT 5.6 starts identically, correctly computing $662 in its internal reasoning. But then it executes a tool call for the incorrect $697 amount, appending an unrequested extra record. This highlights a risk for developers. A model's internal reasoning can be flawless, while its actual tool call is destructive. Many developers in the community suspected a stealth nerf, a shadowy mechanism snapping the dial down on model performance. The community eventually identified a hidden OpenAI parameter known internally as juice. It is an internal compute budget used to allocate reasoning capacity per task. Through model fingerprinting, users discovered that during an unannounced experiment, the juice value for the max reasoning mode was dropped from 960 to 128. This caused the context window to shrink. Users who expected a 372K limit suddenly found their session cap back at 272K. OpenAI's system card admits that high multi-agent invocation rates led to internal usage debugging, which required temporary budget adjustments. This means enterprise developers are building workflows on provider infrastructure that reallocates reasoning resources on the fly without public documentation. The natural engineering reflex is to assume that more reasoning time, using the X-high setting, will solve these execution errors. Looking at the delta between Sol medium and Sol X-high, a configuration adding over 1,000 reasoning tokens, the task success rate remained flat, gaining only 0.2 points. But extraneous side effects, duplicate tickets, and write reversals actually increased. Maximum reasoning effort increases the model's policy adherence, but it also worsens its tendency to over-mutate the state. The compute budget is not a safety margin, it is a configuration toggle that changes the mix of failures you will encounter. Because reasoning can now diverge from action, evaluating a model's prose explanation is no longer a sufficient safety check for production. As we saw in the travel refund case, the explanation is no longer a reliable map of the actual tool call. Teams must shift from prose evaluation to deterministic state diff grading, evaluating the agent solely on whether the final database state matches the target. You must gate the agentic loop. When success is verified, the system acts as a terminal barrier, preventing further action. Developers should instrument specifically for surplus action indicators. Watch for duplicate tool calls and read-write continuations as signs that the model is solving the problem but losing control of the system. You can manage the compute cost of these verification checks by using Amazon Bedrock's explicit cache breakpoints, which allow you to reuse contacts across multiple agent calls. Secure deployment requires treating the model as a powerful but unpredictable actor that must be forcibly stopped by the surrounding environment. We are seeing a divergence in AI, the split between abstract agentic capability and concrete workflow control. The lesson for engineers is clear. Never upgrade a production agent based on a public leaderboard score. Those benchmarks reward unstructured, endless problem solving, which is the opposite of the enterprise requirement for minimal, exact changes. As these models become more capable, your goal isn't just getting the AI to act, it's to build the systems that get it to stop. Terminal state control is the new requirement. Intelligence is only as useful as the system that can contain it.